Good evening, everyone. Good evening, folks. I hear it's quite loud in the back, but we'll make sure we're louder. And we are here for a super interesting panel. Our panel is the ZKML stack, What's Missing? I think that's mostly what the conversation should be about. What is missing in this space? We have three super interesting guests with us. We have Ming, Ismael, and we have Prabal. So I think zero-knowledge machine learning is getting quite a buzz, but from the perspective of someone who does not know anything about it, how would we describe it would be the first question. But before that, a quick round of introductions. I am Varuni. I am the editor-in-chief of the Coin Republic. We're in the news and media business, and these three gentlemen will be introducing themselves right about now. Go for it, guys. We'll start with Ming. I think you'll have to turn it on.
Hello. I think so good. I think
Yes.
It's good. It's good. Yeah. Hello, everyone. Ming again. So I'm the chief scientist of ZKM.
Ming, I think your mic.
Yes. Sorry. Hello. Oh yeah, this is better.
Hello.
Yeah, my name is Ming. Yeah, earlier, you see, I'm wearing the hat of Lazy AI, but to make AI work in the world of Web3, you need proof. So that's why I'm here, like, wearing the hat of chief scientist of ZKM, where we develop an ISA for zero-knowledge virtual machine called ZK MIPS. So this is a very important question actually lurking in the world of Web3. So how do you kind of combine the power of the proof with the power of AI? So I think this is what we're here to discuss.
Good evening. Good afternoon, everyone. Obviously, I just gave a wonderful fireside, or Alice interviewed me for a fireside chat. So I'm one of the co-founders of Lagrange. We are the company behind DeepProof, which is the fastest, most performant ZK machine learning library that's available.
Hello. I'll try with this one. Hi, I'm Prabal. I'm one of the co-founders of Avail. At Avail, we are building a horizontally scalable blockchain. Hello, yeah. At Avail, we are building horizontally scalable blockchain infrastructure, and we want to make seamlessly connected horizontally scalable blockchain as a reality.
Right. So we all know that building something that is both private and practical is still super difficult. That is exactly why we have experts from ZKM, Avail, and Lagrange here to decode everything that we do not understand about this space, as well as also understand what is truly missing. From making sure data isn't tampered with, to checking if AI models actually work as promised, to getting all these proof systems to play nicely together, there is still a lot to figure out. How do we take ZKML from just cool demos to something that actually works out? Will assumptions crash and burn in the real world, or do we actually have products that can bring real world usage as well as adoption? I think first, let's just talk about some roadblocks that we have in today's space. What does ZKML struggle with the most right now? Is it slow proofs? Is it limited model compatibility, or something bigger that we're not talking about? So we can one by one talk about what the roadblocks are. That would be great, starting with Ming.
Yeah. Yeah, at ZKM, we're actually doing general purpose proving. So it's not specifically like a ZKML. But I would envision that a day that the general purpose architecture can be proved, as we can do with like CPU today. Like today, we're almost at the verge to be able to do real-time proofing for Ethereum. So it will be very efficient now, fast and cheap to do it. Like it's since this has first been like kind of like in the open since like 2 years ago. So right now you can prove like the traditional CPU ISA or a virtual machine like EVM in a very efficient, fast way. But I would imagine like in the future, you could probably do like GPU or you could just have very specific, like we do here with precompile, very specific like ML algorithm, like probably like Lagrange is doing. You just take the time to develop this special circuits for those very specialized algorithms. So I think this field is progressing very fast. Yeah, I'm very hopeful.
Yeah, so Lagrange, obviously we're incredibly excited about the future of AI, and we're incredibly excited about what ZK will bring to AI. In particular, there's this saying I've heard a lot of people say in crypto, that crypto needs AI, AI doesn't need crypto. And that is in some ways true when we're talking about a lot of the people launching tokens nowadays, but that isn't true when we talk about the technology being built in crypto, in particular, ZK. When you apply ZK into the AI space, what you're able to do is add safety, privacy, and security in ways that were otherwise not possible before the use of ZK in that field. And so what that enables is a whole variety of new applications that for compliance, regulatory, and then comfort reasons were not possible before, net new, powered by ZK. And that's what makes it very exciting. And obviously at Lagrange, we build DeepProve, which is the fastest ZKML library in the space. So I'm probably a little biased in saying this.
Yeah, I think he wrapped it up pretty nice that a lot of work is being done and a lot of things to be very excited about. I think if I have to talk about pure bottlenecks, there are two sides to the story. One is the demand and another is the supply, right? On the demand side of things, does an average user care about verifiability, safety, about any of this? Maybe not today, but we are always building for the future, right? It was not before you can apply a Ghibli filter to your picture that you realize that there's so much amount of work that has gone into image processing, into digital signal processing, into a lot of the algorithms that were trained on this image data would have seemed like trivial. Like, why are you spending billions of dollars of money into training something for that? But once it is shown, then you cannot go back. The moment you see that that is the kind of impact it can have, the world changes, and we are building for that world. So is the demand there today? Maybe not. But we are building for a future where we think that that demand will be status quo, where we think that every ML output will be verified, will need to be verified, unless it will not be able to upload. Like you see on Twitter today, a lot of bot accounts just posting data, right? But you don't even know from which algorithm it came about, from where did it come, what was the input, and so on. There's zero verifiability, zero privacy, nothing, right? But the moment you show to the world that it is possible, you will not be able to go back. And that's for one part. On the supply side, yes, there is bottleneck, and that's why we have all been working on it. Like, why do you think a bunch of smart folks will work on a problem which is already easy, which is already solved? It is never going to be a problem which is already solved that we are all going to be excited upon. So definitely there are bottlenecks. Definitely there is meaty problems to solve, and there's a lot of betting that we are taking on our future, whether it will work or not, and we definitely think it will.
So I think I'll have to play the devil's advocate here. The three of you mentioned future, and Ming also mentioned how he's super hopeful about the future. What exactly is this future that we are talking about? And when we talk about ZKML, when we talk about combining AI and crypto, how is adoption going to work in the future? If you can describe that future and how we're going to walk towards adoption, that would be great.
Yes. A future of AI is actually something people have been dreaming about in sci-fi for a long time. But the implication, the consequences of actually AI integral to our human society is actually not very clear, because the AI, being kind of driven before are very human-like. But right now, AI is kind of a blend of both a human and tool, right? So you never have a human kind of, for example, the AI we have today, based off LLM, right? The encyclopedia. Yeah, it's with encyclopedia. Not every human is like that, right? So how do you deal with a being like that, right? I think what crypto, ZKML can do is kind of defining boundaries of all these rules. So AI could be an integral and beneficial part in the human world. So I think that's what why ZKML is important. It's not just for tokens. It's not for transactions based off a existing world economic order, right? In a sense, if just for AI doesn't need to use crypto, right? They're machines, right? They don't need to transact based off human. They don't need to trust like human. But ZKML can build that kind of boundary, so we can define the kind of order that works for the existing humans, and also to integrate the very powerful, but yet to be defined as enemy, foe, or friend, right? And with that, I think is the kind of the future that is imminently upon us, and is kind of urgent for us to integrate ZK blockchain and especially ZKML into the development stack of every developers or the apps integrated AI out there in the near future.
So I think it was 2009, Mark Andreessen famously said, software is eating the world. 2005, I can't remember the exact year. But it would be an understatement to now say that AI is eating and has eaten a lot of the world. Realistically, every sector, all the way from finance to medicine to aerospace and defense, is adopting, being augmented, and replacing human intelligence with machine intelligence. I mean, I think it was Anduril that recently said a large portion, if not the entirety of their drone coordination mechanisms are AI. I mean, you talk to hospital systems, and the number one conversation point is, how can we use diagnostic AI? How can we augment, medical professional decision-making with AI? And so if everything is using AI, how do we ensure that that future, the future that we all inevitably know that is going to happen, has guardrails, constraints, and guarantees of safety and privacy surrounding the models used within it? I mean, that's fundamentally what ZK gets at. It is a defensive technology that establishes a guardrail for humanity and human-centric properties that we want, right? Things like privacy of our data, privacy of our information, and guarantees that the models that our lives are predicating many of their decisions on are in fact correctly being used. And to make another point, a lot of agentic systems, agent-to-agent communication, not just human-to-agent communication, but agent-to-agent communication also needs ZK. How can agent A guarantee that it's talking to another model at agent B and not, some intermediary trying to rug it or steal assets from it, or some adversarial intermediary? This is where you start needing AI as you start building, or ZK, as you start building complicated machine systems.
Yeah, I think he good, well mentioned, both of them mentioned the macro of the demand, right? Let's go into the micro of the demand. If you look at the crypto industry and you think that there is adoption, then I would posit that even 70 to 80% of the crypto transactions today are agentic, right? They're all bots. Do you think that they are users? I would definitely argue so. These are the people, or these are the infrastructure for which we are building all the infrastructure behind. There is no world in which you are creating a stock trading platform without high frequency trading, without machines trading between themselves who are eating up opportunity and talking to each other. If it was 10 years back, we could have talked about it maybe having adoption. But today, there is no sector of digital infrastructure where there is not enough agentic systems. And all these agentic systems have to go for either economic security or cryptographic security or no security at all. And when the conditions come to that, people will always choose some level of security over the other, whether it will be a full ZK-based system or AVS or some economic guarantees around it or some network of coordination actors acting on their behalf, which is too big to fail. That we will have to see. But I think the adoption has to come.
How do we measure success when it comes to ZKML? How does the end user sort of measure success, and how do you guys as founders sort of measure success? Are there certain metrics, like is it speedier, is it safer, is there more adoption? If you guys can all talk about that, or is it still in the sandbox phase? I think that's something that we would love to know.
I think in general, the question comes about measurement are different for different stages, right? So for now, it is always about how many computes can you perform per second, or how many instructions can you prove per second, or some derivation of that, right? Depending on which architecture, what platform, etc., etc. But when it comes to large scale, like how do you see whether internet is a success? Like you see like how many people use it, how many websites are visited, how many packets of information flow through the digital infrastructure that we have created, and so on and so forth. Like these will be the metrics for ZKML as well. We will have to see like how many agents are using it, how many queries are being served per second, how many packets of information are verifiable relative to the total amount of information that is being transmitted. So those kind of metrics will come out as success metrics. And even if I would go out and say that even if we have 1% to 5% adoption within those scale, it is going to be huge for this industry, because you cannot assume that everyone will start caring. It will always start with a niche, and then it will become the status quo.
Yeah, I mean, I think that's a fantastic answer. I mean, for us, measuring success is very simple, right? You have the things that people think define success, which is how fast your system is, how cheap your system is, how easy it is to use. But those are orthogonal. The real marker of success is, are people using your thing that you're building, and are they paying to use the thing that you're building? Everything else is secondary to that central point. If nobody's paying to use your thing, then you probably shouldn't be building that thing, right? And so we define success along that category. And I'm very happy to say that we've announced partnerships with 25 AI companies within crypto over the last couple of months. We probably have another 25 in the pipeline announcing soon that are integrating Deep Proof. And we have very, very large Web 2 companies that we have deals with that we'll be announcing soon as well that are also using Deep Proof. That's how we define success.
And I will just, sorry to interrupt, but I will just say, like, for example, with HTTPS, like SSL connections, they become the norm right now. Like if you use a HTTP connection, it is going to be almost impossible to access that web page for anything useful. This is going to look like, you will not realize it, but everyone is going to push it so hard that it will become the norm. And anything non-verifiable is not going to stand a chance.
That's an excellent point. I mean, most people don't know how HTTPS works, and yet their entirety of their online, credit card information privacy is guaranteed by it. So, I mean, it's a fantastic example of, by default, getting something that changes the entire dynamic of the internet.
Yeah, I would like to follow up on Ismael that the real measure of success is actually value, right? So in a Web3 way, the value is a network. So if you can have a network that provides value value, the developers will flock to your network, then that's a true measure of success. And in order to do that, of course, you need to reach certain kind of benchmarks. In my line of like benchmarks is very important, right? So we had this kind of like a leaderboard of like, who's doing what. So, I'm here not just to boast us that we're probably the only one that had meet all the 3 ticks of the ETH proof. But anyway, the true trial of your success is when developers, come to you and try to build value out of it, not just for your value. It's a congregated value of both the developer, user, and your technology. So I think that's the way to see it.
Yeah, that does make sense. In fact, the HTTPS is a great example. If we have to talk about what ZKML is doing today, are we able to verify AI bots, or are we able to verify images? In terms of what is happening today in the space, if we have to talk about the largest sector, where is it at the moment? And I would love for you guys to maybe draw a timeline for all of us here. In the grand scheme of things, where are we currently placed, and what companies, or what I'm sure that your companies are taking a lead there, but are there any specific companies that are doing some amazing work in this space? If so, how is that getting applied in the real world at this moment?
Yeah, so I would say, and I'm sorry for jumping in, guys, but yes is my short answer. Yes. You can use ZKML today. It's available today. We have the fastest library for ZKML, Deep Proof, but obviously there's other libraries too. And we always recommend anyone who doesn't believe me, go independently evaluate, form your own conclusions, and hopefully use Deep Proof at the end of that. And yes, there's certain model architectures that we don't yet support. We are adding support for those. We'll have LLMs in the next version. And I think that's going to blow people's mind when you can start proving the output of LLMs in a performant fashion. And yeah, I mean, there's major companies using this. There's all the crypto ones that we've announced stuff with. And there's major ones in Web 2 as well that we're working with that I can't share today, but you can think of the foundation model companies, the FANG companies, things like that.
Yes, for us, like I said earlier, it's about value capture. So right now we can use the framework of ZKVM, like providing proofs for all kinds of Web3 AI apps, agentic apps, especially to verify the data. And that's what LazyAI network is about. And this is, I think it's the only way to kind of capture AI Web3 apps, the apps, like value into the existing blockchain ecosystem.
I think I would roughly answer it a bit differently and say that, if you think about how far are we, yeah, we can of course do a lot of things. Like these guys are in pushing the boundaries, so it will be very harsh to say that no. But you talked about a timeline, right? The problem is that every day the AI ML status quo is changing so rapidly that these guys have a very, very tough task to keep on catching them up. There will be a time when ZK is going to be very, very matured, when AI ML is going to be very, very matured. And at that point in time, they are going to be very easily be able to, merge the gap, to be able to close the gap and say like, okay, 90% of all queries, we can make it verifiable. Maybe today that is 10%. Again, I don't know, maybe you will disagree. But today it's very harsh for us to, go out and ask them like, are you able to verify 100% of the queries? Because, I mean, even today, like a Sam Altman doesn't know what the performance benchmark of their own team is going to be tomorrow, right? So if we are not at the time when we should be able to close the gap, the most that we can do is like run as fast as we can, fall down as much as we can, and stand up and go far.
I like the broader point about, these are two very emerging technologies that are concurrently rushing forward. The one thing I'd push back on a little bit is I actually see progress in ZK faster than progress in ML along the relevant metrics that are required to prove ML inference. And what I mean by that is the size of models is not growing as as quickly as the performance in ZK is improving, right? Like model architectures now, major foundation models, 80 billion parameters, 50 billion parameters. It's about the same as they were 12 months ago. And ZK is improving by at least an order of magnitude per year in performance. And so we see ZK getting faster and cheaper at a rate that is accelerating quicker than we see models growing in size.
Absolutely. I mean, I fully agree with him, and that's why it has to be so bullish about this particular field, because if you look at the progress in the last 3 years on the ZK field, it has been amazing. People talk about AI a lot, but if you see the benchmark progress, if you take any benchmark and you see the progress in the ZK field, it has been like amazing to watch, and we have been using it, and it has been almost, pretty hard to believe that this kind of order of magnitude improvement can be possible in such a short time. And that is the reason, right, that AI is going to be stabilized. Again, that's a very harsh thing to say, but it will stabilize for some certain use cases. It will, for general purpose use cases, it will probably stabilize quite soon. And from then on, it is only a matter of time on how quickly you can bridge the gap.
Now, Web3 has been plagued with certain problems. One of them is a lot of founders trying to build the same thing. Another one is simplicity. That is something that does not inherently come to Web3. How are you guys at the foundership level, at the exec level, trying to deal with these two issues? Number one, so many people trying to find solutions to the same problem. And of course, teamwork makes the dream work, and yet we have so many different teams playing on the same ground. So how is that problem being addressed on a foundership level?
I think I will just go first. Essentially, there are two things you mentioned, right? One is that I believe if there is a problem which is meaty enough, you cannot avoid competition, right? Like, I mean, it is absolutely foolish to think that we have found a gold mine and no one else has found it, and we will also talk about it. We will do a lot of marketing. No one will notice, although everyone will notice and everyone will, shill about us, but still no one is trying to solve the same problem. So I don't think it works that way. I think each one of them, I would say that I can only talk for myself. I think we are confident enough in ourselves to think that we will be able to solve the problem, and that's why we are in it. We openly collaborate with all the people, because that's one of the beauty of Web3, which is probably not seen in traditional markets, is that how much we collaborate among ourselves, although we are probably in a similar field or allied fields and so on, because we believe that even if collectively we are able to grow the pie, it is going to be win-win for everyone. So that's one thing. And the second is simplicity-wise, as I mentioned, like, I mean, we are not, at least I would like to believe that we are not, foolish enough to think that, everyone will understand the code differences, like what does 80 billion parameters mean? And no one cares. Like 80 billion is a big number, maybe good thing, maybe bad thing, I don't know. And that's okay. As long as the end user is able to reap its rewards without understanding its complexities, I would say it's a win.
So I want to address the point about people building the same thing. And so I've been running a ZK company for about 4 years at this point. And when I founded Lagrange, there was one application in ZK that anyone paid for, and that was proven EVM block space. I've been to many ZK summits, many ZK conferences. I've traveled the world talking about ZK, and now we are 4 years later. And do you know how many use cases people pay for in ZK meaningfully today? One. The exact same use case as 4 years ago. But the only difference is, instead of there being two teams, Polygon and ZK Sync, targeting proving EVM block space, there are now 20. There's a bunch of ZK VMs. There's a dozen ZK rollup teams. I mean, there's so many people going after the same problem. And so I love ZK. I believe this is a fundamental technology that will transform almost every industry. And what we endeavored to do at Lagrange was target something else, to target a use case that we believed actually had PMF and that wasn't the same thing that everyone else was going after. And that is, how do we prove very, very large ML models with ZK with as performant a specialized prover as possible? And then how do we commercialize that agnostic to sector?
Yeah, actually, I'm one of those like 24. Yeah, like
You're the best.
Yeah, we're okay. I think what we are trying to surprise us to is what we call like an overflow phenomenon, because when some technology has a crowded solution provider, a positive way of thinking is that this technology will overflow to other unexpected use cases that need the technology but wasn't even possible to think in the first place. So I'm glad like Ismael and your team found this big use case in ZKML, because of the need for to prove this all kinds of like models over there, right? How can you trust the model, everything? We have found that it's not just for Ethereum, because Ethereum built all this awesome technology, but why can't we just use the example for all blockchains, right? Why can't we build a very efficient proof of any computation for all the blockchains, including blockchains that develop AI agentic Web3 applications. They need them the most because, of all the apps, Web3 AI apps is probably the most problematic, right? Because they don't have a centralized authority to be trusted upon. They can only rely on user contributed data, user contributed behavior. And for that, you need a generalized, universal computation proof framework, which is what ZKVM is very, very good for. And I'm really happy that we're one of these 24 teams that build this technology so that you can have a choice. So it's a start. I think it's not to be seen as a very, so many teams, competing for the same thing. There's a reason for that, and it's meaning the technology is going to overflow to other fields of application. And I'm very optimistic, actually.
Wow, this session has definitely been about a lot of optimism, and it has surely been insightful for me and for the ones who were listening. Any closing remarks so that we can quickly wrap up this super exciting session? Ming, we'll start with. Go for it, Prabal.
Yeah, I think I would just go on to say, like, if you're a developer who is looking to work on this particular space, please talk to all the different teams, talk to them, and such. If you are looking for verification of such and how does different blockchains and different verifiable compute can talk to each other, like, come to us. If you want to know about how encrypted data can be published while still being provable, looking forward to announcing more towards this week about how we are trying to change the status quo of what does it mean to have verifiable data published for verifiable computations and such.
Yeah, I think that's a great closing remark. I guess my final closing remark, I want to make a controversial one. So today we have the ZK AI Summit. There's going to be other ZK AI Summits this year, I promise you. And there will hopefully be more ZK AI Summits next year as well. I hope 3 years from now, there's no more ZK AI Summits. There's just AI Summits. And ZK is by default included within major AI companies. That's what I'm hoping for. The same way there's no HTTPS summit, there's no, there's no secure encryption summit for the web anymore, right? You just have by default the inclusion of security relevant properties and a fundamental general purpose technology.
I'm actually from what do we have here today? What the audience, right? So it's so exciting. It's more than I expected. There's so many people. That means what I have been thinking all along is that ZK plus AI, this is a happy marriage, and it's probably the most important marriage of technology since Satoshi Nakamoto kind of first invented Bitcoin. So let me say that I'm awed by this. I'm awed by the everyone here. Yeah.
Thank you so much, gentlemen, for beautifully putting how this future is going to look for all of us. And I'm sure we are all super excited for this amazing future that we spoke about. Once again, thank you so much. And thank you, everyone, for being a really patient audience. Thanks.
Thank you.